Next, we're going to look at what are irrational numbers. So when it talks about irrational numbers, we're talking about a number that cannot be written as a simple fraction. So anything that can't be written as a fraction is going to be irrational because the decimal goes on forever. So let me give you an example of that. Pi. Pi is an irrational number. Now we say that it's 3.14, but that's because we're actually rounding it. Actually, the decimal goes on much further. And I'm going to show you with the calculator real quick what I mean. So if I go ahead and hit the pi button down here and hit enter, and I hit enter a second time, you're going to see that it says 3.14159. So let's go ahead and I'm going to click up on it, highlight it, and hit enter. So now look at that. It's 3.1415926535898, and it actually continues to go on forever. It's a non-terminating decimal, and this is an irrational number, and you cannot put this into a fraction form. And let me show you what happens if we tried. If I go to numbers and I go to approximate to fraction and I hit enter twice, it gives me some crazy looking fraction. So that this tells you that this is irrational. The neat thing is, anytime you have a number and you're trying to classify it, you can actually put it in your calculator and see, does it have a non-terminating decimal like this pi number does. And if it has a decimal strand that goes on for a very long time, then you know that it's going to be irrational. So I'm going to go ahead and continue to write that decimal strand. We said it was 3.1415926535898. Now, that was really long, right? So we know that that is an irrational number. Let me give you another common irrational number that I see all the time. The square root of 2. So if we do the square root of 2, let's go ahead and put that in our calculator and see what it looks like. Hit Control and then hit the x squared button, and it gives me my radical sign, and I can put a 2 in there and hit enter, and notice it gives me a long strand again. When I see that long strand, then I know that it is going to be irrational. The only exception to this would be if the strand was a repeating decimal. So if I hit enter and expand it further, you see that it's non-repeating. In other words, it's random and it's non-terminating. So we have 414-213-562-3731. When you see these random numbers, there's no pattern in it, then you know that it's irrational. I am going to give you an example of a number that has a repeating decimal that is rational, and that way you can see what the difference is. For instance, if I said 0.333333 and I just went on forever, that's actually a rational number, because even though it's non-terminating and it's repeating, this actually can be written in fraction form because it has a pattern. The pattern is that 3 repeats itself. So if I hit menu and I go to number and I go to approximate to fraction, it'll actually give us a valid fraction. I'm going to give you one more, 0.666666. If I keep on doing sixes and then I hit menu, approximate to fraction, it's going to give me 2/3. So keep in mind that if there's a pattern, then it's going to be rational. If there is not a pattern in the number strand, for instance, let's do one more, square root of 11. Notice there's no pattern there. If I expand it, it's just random numbers. So if it repeats the same number over and over again, it's going to be rational. But if it's a long strand of numbers that are non-repeating, that are just random, it's always going to be irrational.